So today we're going to look at perfect squares. So this is a perfect square, x by x, which gives me x squared. So if it was 5 by 5, it'd be 25. If it was 10 by 10, it'd be 100. Whatever, it could be 5.5 by 5.5, whatever that gives me. So we're going to look at factorising, going from plus and minus to a multiply of perfect squares. So the first example I've got is x plus 1 all squared. So here I've got my extra little one coming on. So this is 1 and its length is x. So this is x plus 1, x plus 1. There's a little hole here, so I need to put a 1 in here. So this represents a 1, because 1 times 1 is 1. So x plus 1 all squared is x squared plus 2x plus 1. That's what I've written down here. X plus 1 all squared is x squared plus 2x plus 1. If you wanted to expand it out using the brackets, of course you could. The next one, x plus 2 all squared. So instead of having it 1 wide, I could have it 2 wide. So now this is x plus 2, and here I've got x plus 2. But now how many little squares do I need? Well, I need more than one. Let's have a look. 2, 3, 4. And that's because I've got 2 times 2. So x plus 2 all squared is x squared plus 4x, 1, 2, 3, 4. X squared plus 4x plus 4. And that's what I've got written down here. X plus 2 all squared equals x squared plus 4x plus 4. You could do it with the long way with brackets too. Let's have a look at x plus 3 all squared. So then I would add on another one. There's x plus 3. There's x plus 3. Oops, I need a sideways one, not a upside down looking one. There's x plus 3 all squared, and now I need, put some more little squares on, an extra. How many will I need altogether? 9, because now I've got x plus 1, 2, 3, so x plus 3 times x plus 3 is x squared plus 6x, 3 here, 3 there, 2 lots of 3, x squared, 6x, and 9 more, 1, 2, 3, by 1, 2, 3, 3, 6, 9. So that comes from the 3 times 3 is 9. So I've got 2 lots of 3x and my x squared. So there it is. X plus 3 all squared is x squared plus 6x plus 9. You could do it this way if you wanted to. The next one I've got is x minus 4 all squared. So let's have a look what that looks like. So instead of plus, I'm going to use pink for negative. So I've got, what did I say, x minus 4. So 1, 2, 3, 4. And 1, 2, 3, 4 this way. Now let's have a look what happens. Okay. So here is x This is -4, so I'm using pink to represent -4. So this would be a minus x block. Here I've got 4 pinks as well. That's a -4. So I've got x minus 4 times x minus 4. That's my square. So I've got x squared. I've got 2 lots of -4x. 2 lots of -4x. So that would be minus 8x. And here, this is -4 times -4, which is plus 16. So x minus 4 all squared is x squared minus 8x in pink plus 16. So that's what I've got here. X minus 4 all squared equals x squared minus 8x plus 16. And if you expanded that out, that's what you know, using those brackets, that's what you'd get. So that's flicking between a multiply and an add. Multiply and an add. Don't know if you noticed, but every single square has the form. That's the first part squared. This is the second part squared. So for example, x squared, 1 squared, x squared, 2 squared, x squared, 3 squared, minus 4, 16. See the pattern? And the number that's in the middle is always 2 times whatever the product of these two is. So 2 times x times minus 4 is minus 8x. 2 times. So the general rule for any perfect square, if you write it like this, is a squared, that one's b squared, and the bit in the middle is always 2ab. So let's have a look at factorising x squared plus 10x plus 25. So here's my x squared, here's a pile of 10x's, and there's a pile of 25. Let's get to it. So if I've got to share out 10x, sorry, 1, 2, it's got to be symmetrical too because it's a square, yeah? 1, 2, 3, 4, 5. And down the bottom, I also need to have 5 because I've got 10 altogether. So here I've got 1, 2, 3, 4, 5 as well. So there I've got my x squared. Here's my 2 lots of 5x that make 10x. And then I will just fill in all of these to fill up the 25. Okay, can you trust me that there's going to be 25 there? Because I reckon by the time I fiddle around with all of that, it's going to be too long. So that would be nicely in a grid. So what I've actually got is x plus 5 times x plus 5. Both sides are equal, it's a square. So x plus 10, x plus 25 is x plus 5 all squared, because its length and its width are x plus 5, x plus 5. If this had been x squared plus 11x plus 25, it's not a perfect square. If this had been x squared plus 10x plus 24, it's not a perfect square. It's only a perfect square when you see that this 25 is 5 squared, and this is 2 times the first one times the last one. So this is x squared plus 2 times x times 5 plus the last one squared, which is 25. That's how it always goes. You could check that yourself. There's x squared, whoops. There's 5x, there's another 5x, and there's the 25. So I've got x squared plus 5x, which is 10x, plus 25. So it doesn't matter which way you go, it's always the same. Here's the last example, and the first thing to make life easier for yourself is to take out a common factor. Can you see that every one of these ends in a 0, so 10 must be a common factor. So let's take that out to start with. So I would get 10 lots of 4 is 40x squared, 10 lots of 12 is 120, so I would get 12x, and 10 lots of 9 is 90. So now I've got to start looking at this and saying, well, it's 10. I'm just going to use square brackets to make it easier to see. Can you see that this is 2x all squared? 2x times 2x is 4x squared, minus 12x plus 3 squared. Oops, sorry, that should be a square bracket. Oops, daisies. Yeah? Now, the easiest way to check if this is a perfect square is to check this middle term. So this middle term has to be 2 times 2x times 3 to be a perfect square. 2 times 2 is 4, 4 times 3 is 12, so it has to actually be negative 3. So this is actually negative 3 all squared. Oh, that's a bad. Let me write that again. Because if that wasn't a negative 3, I wouldn't get a negative here. Okay? So let's have a look at that as a picture. This is 2x minus 3, 2x minus 3. 2x times 2x is 4x squared. 2x times minus 3 is minus 6 lots of x. Minus 3 times 2x is minus 6x. Minus 3 times minus 3 is plus 9. This gives you a total of negative 12x. So I actually have 4x squared minus 12x plus 9. So that must factorise to be 2x minus 3 all squared. 2x minus 3 multiplied by 2x minus 3.